That's a hard section. Okay, so remember the steps. Let me remind you of the steps for the, well, steps. But I hope you're getting the hang of this whole thing. Greater than or equal to. So on the exam we take a couple weeks, right? 2 weeks. What's today? 19th. Yeah, 2 weeks from today. 2 weeks from today, we have exam number 2. Proc exam's already out there available. So recognition's a lot of the battle. How you're going to recognize these? Greater than, less than, right? These are the only ones that'll be on the test in 2 weeks. Greater than, less than. So we see greater than, less than. There's 2 types. There's the fraction kind and the non-fraction kind. Now, if you notice, there's different ways we handle the greater than, less than fraction and the greater than, less than non-fraction. So this is fraction, clearly. So what do you do for the greater than, less than fraction? Well, first step's the same in both. Get a 0. Second step, you have to make it, I think I wrote it a little differently last time. This is, I think, a little better. Get a 0, make it 1 fraction, right? That's what we need to do. Get a 0, make it 1 fraction. And then step 3, you graph by the table, Table for each section, which we did. So maybe that's a better way to say the steps that we go through. So get a 0, make it 1 fraction, common denominator, combine, and then make a graph. Okay, so jump this over. Let's do that. So we have 1 over x minus 7. When you jump that over, it becomes minus 4 over 9x minus 6 greater than 0. See, I did step 1. I got a 0. That's always what you use. You want to have these steps, with you when you take the test. Put it on your 3x5 card, right? Really, remember what I talked about last time? Really common mistake is people try to multiply. A lot of people say, well, I'm just going to multiply both this side by x minus 7, and that you can't do that. Why not? Why can't you just multiply both sides by the common denominator instead of my whole get a 0 thing? Because you don't know what x is, so you don't know whether to turn the symbol or not. Right? Did everybody catch that? Really common mistake. Because if this was equals, literally, I mean, if you guys are a typical class, 30 to 40% of you, 2 weeks from today, will look at this very kind of problem on the exam, and first step, you will multiply both sides by the common denominator, and everything else is garbage from that point forward. It'll be completely wrong. So I don't want that for you, so I'm doing all I can to warn you, to sound the drum. Don't do that. Don't do that. If it was, and I know why it's so tempting, because if it was equals, that's what you do, For equals, that's totally the right thing to do. But with equals, you don't have to worry about turning a symbol. That's why it's okay for equals. But if you have a greater than, less than, well, you can't multiply by anything that has an x in it, because you don't know what x is. In any version of x minus 7, 9x plus x, you don't know what x is, so you don't know whether that whole thing, 9x minus 6 or x minus 7 or whatever, is positive or negative. So you don't know whether to turn the symbol or leave the symbol. You don't know. And that's not a small deal. You can't say, I don't know, I'll worry about it later. No, that's gigantic. You need to know, turn that symbol if you're multiplying by negative. Don't turn that symbol if you're multiplying by positive. And we don't know what we have. All right. So I hope that makes sense. You can't do that. That's why I give you all these steps, guys. I'm always shocked when I work with students and I give these steps and they're not using the steps. And then some people just are fine. They got their own method. But I'm talking about people that are getting it wrong. And I'm like, I gave you steps. Why aren't you following the steps? They're there to help. It's like a recipe. Make the cookies. There's the steps. So step number 1, get a 0. Step 2, make it 1 fraction, and then graph it from there. So let's do that. So step number 1, get a 0. So put that on your 3x5 card. There's the 0. And now make it 1 fraction. So we got to put those together in 1 fraction. So how do we do that? I'm going to multiply top and bottom. Top and bottom is fine. You see what I'm not multiplying left and right. I'm just multiplying top and bottom of the fraction. Of each fraction, right? So I'm not really changing the fraction. Notice I'm not going right side, left side of the symbol. That would not be allowed. Okay, so when you do that, what happens? Well, you get the common denominator. See how I made both denominators be exactly the same? Right? They both have an x minus 7 and a 9x minus 6. X minus 7 and 9x minus 6. See that? Both of them? Yeah, Cyrus?
So when you bring the fraction over to the other side to make it 0, nothing in the fraction changes besides just having a minus in front of it?
Right, because a fraction is just like anything else. Really, I just subtracted 4 over 9x minus 6 from both sides. Does that make sense? Yeah, so just like any object that you're getting rid of when, from one side, you're just subtracting. You're just doing the opposite, right? So yeah, just the minus goes to the front. So what happens here now? This 1 is going to go boom, boom. So I'll get 9x minus 6. That 1 just distributed. Now, did I mention last time? Probably if I was to make a top 10 list of common algebra mistakes, this might be number 1 or 2. Is it's so easy to forget about that little minus sign back there. What I've seen a ton of, I mean, like 70% of the people, like more than half, it's why it's like number 1, number 2 on the list, will go like this. They'll look at the 4 and they'll go, okay, 4x minus 28. And then they'll go, oh, yeah, it's negative. They'll kind of remember it at the last minute, and they'll put it there, but that's too late. That minus 4, this should be plus 28. That's the mistake they're making. So, to help you with that, to not make that mistake, so important, put that minus right on that 4. That's his baby, right? That's going to go with him wherever he goes. So let that minus 4 go to the x and go to the 7, plus 20. That's the part people forget. They get a minus 28 back there. And then everything's wrong, and Math Excel keeps hassling you and saying no, and you waste hours of your life. So don't do that. I'm trying to save you from all that trouble. Right? So the signs that are in the front right here, put them right on. A minus that's in front of a fraction, it goes to the top of the fraction. You could do the bottom, but you don't do both, right? Are you comfortable with that rule? Like if I put a minus in front of a half, you can put it on the top only. That's correct to do. Or you could put it on the bottom only, but you can't put it on both. Why?
That would make it positive, right?
Yeah, 2 negatives would be positive. That's not right. So you could put it on the top only or the bottom only. We don't want to put it on the bottom, right? The bottom's common denominator. We don't want to mess with the bottom. So I put it on the top only. So do that, so you don't forget about it, and you don't mess up your signs. Okay, so we get to there, and now we just combine stuff. 9x minus 4x is 5x. Minus 6 plus 28, was that 22? Over, oh yeah, this one does have a little more trouble afterwards, huh? Okay, now let's go. So we good to there. So that's all that's step number 2, make it 1 fraction. So step 1, we got a 0. Step 2, we made it 1 fraction. Good to there? Now, step 3, we have to graph by making a table. So, first off, we have to get our sections. Remember, we find what makes the top, the 5x plus 20, we've got to find out what makes that 0, and then what makes the bottom 0. Whatever makes the top 0 is an x-intercept, and whatever makes a 0, we call it, or an x-intercept. Whatever makes the bottom 0 is what? What does it become on the graph? When I find what makes 7, for example, positive 7 is going to make that part 0. What does that mean about positive 7 on the graph? Vertical asymptote line, right? Whatever makes the denominator of a fraction 0 is undefined is a vertical asymptote, right? So whatever makes the top 0 is a 0, or makes the bottom 0 are vertical asymptote spots. So let's find those. Now this one's obvious, positive 7, no problem. But how do you find out? That one's not so clear. Like, how do you find out what do you plug in for x there? And how about the top one? That one's really weird. How do you find out what plugs into x there to make those pieces 0? You just set them equal to 0 and solve. When they're too hard to tell by just simply looking at them, then just go ahead and solve it. What I mean is take the 9x minus 6 and just say, hey, what's going to make you 0? Just set it equal to 0 and solve. So move over that 6, like that, divide by 9. 6/9, reduce it, 2/3. Isn't that good? 2/3 will make that piece 0. How we doing? I'm seeing some maybe just some pensive looks. Is that okay? And then the top, say, what's going to make that 0? Well, same kind of thing. Just take it off to the side and say, okay, 5x plus 22. What'll make you 0? Jump that 22 to the other side. Minus 22, divide by 5. I would get a decimal, just easier, I think, easier to work with. You just divide in your calculator. It's 4.4, isn't it? So I think it's just easier than leaving it 22/5. 2/3, I just left 2/3 because I think we're comfortable. It's whatever's easier for you. You can make this one a decimal also, 0.666, or 0.7's close enough, whatever. I would leave that one 2/3. It's probably easier just to leave that one 2/3. And this one I'll make a decimal, minus 4.4. Just whatever's easiest for you. We have to put those on a graph now, right? We're okay to there. I'm going to get a fresh screen if you've got that down. So 5x plus 22, so let me rewrite it. So 5x plus 22 over 9x minus 6x minus 7. Was it greater than 0? Okay, is that okay? You guys, questions on that part? Can we keep going? So now we've got what answers? We got a 7 and a 2/3 and a minus 4.4. These guys are going to be verticals, vertical asymptotes, aren't they? And this guy will be a 0 or an x-intercept. It'll be the only place where the graph actually hits the x-axis. You know, whatever makes the top 0 are zeros. Whatever makes the bottom 0 are verticals. Vertical asymptotes, aren't they? Okay, so let's go to the graph then. So we've got 2/3 and 7 for the bottom, and the top we've got, whatever it was, negative 4.4. Okay, so let's go to the graph. So negative 4.4 is over here. That's going to be an actual 0. And then 2/3, say, is like right there. And then 7 is another vertical. So we have actually, what, 4 sections? We have, do you see what I'm talking about? Right, because there's 3 breaks. So if I take a stick, I take this ruler, and if I cut it once, I've got 2 pieces. If I cut it twice, I've got 3 pieces. So I don't have a third hand here. But if I cut it 3 times, I'm going to have 4 pieces. There's always one more piece than cuts. So I have the section number 1 up to the 4.4. Section number 2 between the negative 4.4 and the 2/3. Section number 3 here. Section number 4 there. So basically, in those 4 different sections, I need to find out, is it above or below? Is it? And all I need from my table, I'm going to make my table now. All I need from my table really is positive or negative, huh, guys? Because in the end, I just want greater than 0, which means positive. I want the positive sections. Sometimes we have less than 0. But on that first step, we always get a 0, which is convenient because then in the end, all we need is positive or negative, because that tells the story whether you're above 0 or below 0. That's why we do that, to make life easy at the end. So, okay, so for each of these sections, all I need is positive or negative. So let's pick a point that's in the left section. That'd be like negative 5, maybe. Or you could do negative 6, negative 7, whatever. You know, any point you pick in that section, plug it in and find out whether the graph is above, positive, or below, negative. Because whatever it's doing at one point in that section, it's doing everywhere in that section. So let's plug in negative 5. So we'll go to the equation here. And I'm plugging into this, aren't I? So 5.
Would you get the same answer if you plug it into your original problem?
Yes, as long as it has the 0. Yeah, any version that has the 0. You've got to have the zeros. Yeah, so not the first,
Yeah.
but the one where I first got the 0. Anything that has the 0 would be fine. You got but it's compared to 0 that we've got to do. So 9 times minus 5 minus 6, and where's it, minus 5. So be careful, use your calculator. You know, I think it's somewhat easier just to go negative positive. I don't know if you feel that way. Like, I just look, rather than, it's easy to hit a wrong button, I would just look up here and go, okay, negative 5 times positive 5. I would just do the top real quick on my calculator. It's negative 25 plus 22. That's negative. Or negative 3. It's negative, right? The bottom, this part, is negative 45 minus 6. That's negative. Times, and this part, negative 5 minus 7, that's also. So that's negative over negative times negative is positive. Negative over positive, this is negative. That's all I care is negative or positive. So that means at negative 5, it's down here, which means it's always down here. And then it hits at minus 4.4, doesn't it? See, it's negative in the negative 5 zone. Is that okay? Am I losing you there? There's things you're going to do next semester if you take calculus that's just like this with derivatives. You'll do this kind of negative positive thing. So it's an important skill. Is that okay what I did? So you just type it in your calculator? Yeah.
What if you get a value that's greater than 0?
So that'd be positive.
Yeah.
Yeah, so we'll get some of those in a minute. Then I would say, okay, the graph is positive. It'd be up here instead of below.
Yeah,
So negative is below, positive would be above. I'm just drawing where the graph is.
okay.
So I know the graph is negative in this section, because I got a negative. Okay, now I know it hits 0 here, because that's a 0. Now, is this a pass-through or a bounce? Yeah, look, negative 4.4, where did he come from? He came from this piece right here, didn't he? What's the power? There's no power, it's 1.
So it crosses.
So it's odd, and so it's a pass-through or a cross. Yeah, so it's a pass-through, isn't it? So that's real nice. That means it must go up after that. So I don't even have to test section number 2 if I don't want to. You could doubly verify it if you wanted, but I know it's got to go up there because that's a pass-through point. Now the verticals, I got to test between the verticals because I don't have a pass-through bounce option. But I know this is a pass-through point because the 5x plus 22 has no power on it, which really means first power, which is odd, and odd powers are pass-throughs, right? That's what the negative 4.4 came from, is when I solved 5x plus 22 equal to 0, right? Good there? So I don't have to test section 2. You could, if you weren't sure you wanted to doubly verify, you could put in like 0 or something, and you would get a positive. I'm confident you would get a positive number because the graph is positive. It's got to be in that section. Does that make sense? So it's negative in the first section. It's positive in this second section, going up to the vertical. Now, what about in section 3? Well, I don't know. Just gotta check it. So let's do a point. Like, how about 1? That'd be easy. 1 or 2 or 3, 4, 5, 6. Anything between 2/3 and 7, is fine. Whatever it's doing it everywhere in that section. It can't be up sometimes and down sometimes in that same section because there's no cross points, right? There's no intercepts. So at 1, let's just do 1. It's a nice easy number. I'm going to plug in 5 times 1 plus 22 over 9 times 1 minus 6 times 1 minus 7, like that, which equals positive on the top, right? This is positive, and this is negative. So what is that thing overall? Negative, huh? Negative. So it's doing something like this. I don't know exactly. I don't care a lot. But it's down. It's never positive in that section. Is that okay? See how I'm doing that? And then finally, to the right of 7, the last section, what's it doing over there? I don't know. Plug in something like, what's to the right of 7, like 8? Plug in 8. Come over here. 5 times 8 over 22. Probably everything's just positive. Yeah. See, it's all positive. It's going to be positive over positive times positive. So that just means positive. At 8 is positive. So it's doing something like this. Up there. Graph must be. Because it doesn't hit 0. And it was positive at 8, so it's always positive in that section. Okay, so we got a rough graph is what we got. So we're ready to finally answer the question after all that work. What is the question? The question is, where is the thing greater than 0? Well, here. Like if you're a little person walking back and forth on the x-axis, where would you see the graph greater than 0? There and here, huh? Those two sections, you'd see the graph above, greater than 0. So where would that be on the x-axis? That would be between negative 4.4 and 2/3, that section, and from 7 to infinity, huh? So between negative 4.4 and 2/3 and 7 and infinity. Those would be the two sections on the x-axis. So negative 4.4 to 2/3. I think, and they do want u's, I think. I was doing commas yesterday. They want u's in this section. 7 to infinity. No brackets on anything because we never had a bar. Remember that if it's greater than or equal to, the bar leads to brackets. But if there's no bar, it's no brackets. It's just like that right there. And probably they don't have negative 4.4. They have whatever that is, negative 22 fifths. But yeah, they probably want negative 22 fifths instead of the negative 4.4. You okay with that's the same thing, right? Back over here. See, I had that, and I wrote it as negative 4.4. It's the same either way. Good. That's a tough one, huh? That problem alone takes a long time. This homework done right, at least 2 hours. Unless you're like a lot smarter than I was when I was in pre-calc. This would take 2 hours of my life for sure to do a good job on this section and really understand, really master these problems, so that on a test I could do them. You know, it's a long. Okay, so word problem. What positive numbers 2 times the cube of a number? 2 times the cube of a number, 2x cubed, exceed, what does exceed mean? Greater. If you exceed something, you're greater than it. 8 times its square. 8 times its square. Is that good there? 2 times the cube of a number exceeds 8 times its square. Like that. Okay, so there's our equation. How do we solve it? So remember, it's good to do one more of these. So the steps for greater than, less than kind of questions for a non-fraction. So how do you do greater than, less than for a non-fraction? That's what we have here, right? It's not a fraction. Step number 1, remember, get a 0. It starts out the same. Get a 0. Step 2, remember, is factoring with the parentheses. Factor with the parentheses. And then step 3 is to graph it. Graph it. And for the graphing, we don't use the table. We use the, what's it called, the in behavior. Remember that? You don't have to work so hard. Just in behavior and the pass-through bounce thing. And you can get the graph pretty quickly and easily. You don't have to work so hard with the table making and all the positive, negative. You only have to do that for the fraction ones, right? Where you got to, because those vertical asymptotes, we don't know what they do on the, we don't. That's not a pass-through bounce thing, so we have to plug into tables. Okay, so let's jump this. So let me do a couple steps just to remind you on this one. I'll just do it quick though. Jump that over there like that. That's step 1. Get a 0. Step 2 factor would be 2x squared. Right, because 2 goes into 2 and 8, and then you take out the lower power, which would be x squared. What does that leave inside? 2x squared times x, 2x squared times 4, like that. Is that good? And then from there, you set each part equal to 0. So what's going to make that 0 is just 0. It's just 0. And what's going to make that 0 is 4. Then you quickly go to the graph. You got 0, you got 4. You don't have any vertical asymptotes. That's nice. They're a pain. And so we got 0 and 4. Which ones are pass-through bounce? Well, 0 is an even power, so it's a bouncer. This one's a bouncer. This one's an odd power, so it's a pass-through. So this one's a pass-through, the 4. It's all about the power, right? Odd power, pass-through, even power, bounce. That's why x squared is a U-shaped graph. It bounces, huh? Even power, everything's positive. So that, okay, and then what's the end behavior on this one? Well, it's right there. It's 2x cubed, huh? If you FOILed this out, the first term, the most powerful term, would be positive. Positive means up. If the most powerful, in the end, over here, way off to the right, you're plugging in 100, 1,000, 1,000,000, the most powerful term will dominate the scene. He'll take over from the lower terms, and if he's positive, he goes up. If that was a negative, he would go down. So in the end, if I multiply that out, most powerful term, positive 2x cubed, it's going up after the last 0. It's going up. It'll never come down again. I mean, it might go up and down, but it won't ever cross the axis again. That's what I mean. These are the only 2 places, right, where it hits the axis. It can't ever cross below the axis again. We found the only place. It's real powerful to find the places where it hits the axis and the verticals. You really know a lot about it. All right, so it passes through, bounces. So there's the general graph. And then what do they want from us on this one? They want greater than 0. Greater. Where's it greater than 0? Here. I mean, just there, huh? For a little person walking around on the x-axis asking where's the graph greater than 0. It's there. Which means 4 4 to infinity, doesn't it? 4 to, no bracket because it's no bar. It's just greater than 0. 4 to infinity, which is there, or greater than 4. That's how they want us to say it. Is that good on that? So we've done the two kinds again. The non-fraction, which are a little easier. You can get the graph with the in behavior and the pass-through bounce. And the fraction ones where you got the verticals, you got the stuff on the top and the bottom, the verticals are on the bottom, and you got to make a table. And they're going to have us do it the new way. I'll show you what I mean. So f of x equals square root of x to the fourth minus 1. Remember what we've learned about domain when we have like a function equal to the square root and we have the inside? Remember, domain is asking, what are you allowed to plug in? Like, for a microwave oven, you're not allowed to put tinfoil in, kind of thing. So what we learned about a square root? What can you not put in a square root? You can't put negatives because it's imaginary, huh? So we always take out the inside and say, hey, inside, you got to be greater than or equal to 0. Inside's got to be greater than or equal to 0. So that's what we do here. Grab that x to the fourth minus 1. We say x to the fourth minus 1, you've got to be greater than or equal to 0. Well, then what are you going to do with that? Well, then that's your first step would be factor x squared minus 1, x squared plus 1, right? Excuse me. And then this part factors again, x plus 1, x minus 1. What about x squared plus 1? Does he factor more? No, it's real important to know that. I hope everybody knows that's not x plus 1, right? Just causes so many troubles. I don't want it to trouble you. Right? Does everybody know the plus can't factor, huh? It just comes down just as it is. Stays as it is. And so there it'd be factored, and what are the zeros? What makes that part 0? Negative 1. What makes that part 0? Positive 1. What makes x squared plus 1 0?
Nothing.
Nothing. Good. No, Raul's got it. Nothing. Right? Because anything you plug in squared is going to be positive. And then add 1, it can't be 0, huh? It's got to be positive. So anyway, I don't want to do any more of that problem. You get the idea. I'll just go dot, dot, dot. Is that okay? I used to hate it when math teachers did that. But now I kind of think there's some good reasons. All right. So, okay. The whole key is this last part of the sentence. Average cost no more than 140. Let me write that. Average cost no more than 140. There's our inequality right there. Average cost. What's average cost? Well, they say right here, average cost is given by that. So average cost is that formula. 40x plus 5,000 over x. So there's average cost. No more than.
Less than or equal to?
Good, because if it's not more, then it's less or equal, huh? You could be equal if you're not more. So not more means less or equal. Exactly right. And then there's the 140. So there's your inequality. So fraction greater than less than, what do? Multiply both sides by x. No! But that's such a common mistake. Why can't I just multiply both sides by x? I don't know if x is positive or negative. I don't know whether to turn this symbol or not. If that was equals, that would be exactly what I would do, right? But for greater than less than, we can't do that. I know you're probably thinking, Mr. Henry, you said that 27 times. I know. I'm hoping nobody does it on the test. All right, so and then 40. So you would bring it over, right? So the steps would be bring that over, get a 0, and then common denominator, right? Maybe we'll do one more step. Put that over 1. You multiply top and bottom of that one by x. So they have the same denominator. Combine them into one fraction. 40x plus 5,000 minus 140x. Like that, right? And then we'd have 40x minus 140x is minus 100x, right? Yeah. Plus 5,000 over x less than or equal to 0 and dot, 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 right? Find what makes the top 0, what makes the bottom 0. Vertical asymptote is going to be 0. And away you go. Make the table, do the graph, do the whole thing. Hours of your life, huh? Sorry, this is a really long section, So I'll leave it.